Selenium is a powerful open-source framework designed for automating the testing of web applications across various browsers and platforms. It consists of several components, each serving a unique purpose. Selenium IDE is a browser extension that lets you record and playback tests easily. Selenium WebDriver provides a programming interface to create and execute test scripts, communicating directly with browsers. Selenium Grid enables parallel test execution across different machines and browsers, enhancing efficiency. Together, these components make Selenium a versatile and widely adopted tool in the world of web automation testing. One of the main reasons Selenium is so popular is its impressive set of advantages. It's completely free and open source, making it accessible to everyone. Selenium supports multiple programming languages such as Java, C#, Python, Ruby, and JavaScript, so you can work in your preferred language. It also works seamlessly with all major browsers and operating systems, including Windows, macOS, and Linux. Integration with popular testing frameworks like JUnit and TestNG, as well as CI/CD tools like Jenkins, further streamlines the automation process. Locators are essential in Selenium for identifying web elements on a page. Selenium WebDriver supports several types of locators, including ID, name, class name, tag name, link text, partial link text, XPath, and CSS Selector. Each locator type offers a different way to pinpoint elements, making it easier to interact with dynamic and complex web pages. Choosing the right locator is crucial for building robust and maintainable automation scripts. Understanding the difference between absolute and relative XPath is key for effective element selection. An absolute XPath starts from the root node and follows a fixed path, making it fragile if the page structure changes. In contrast, a relative XPath searches for elements anywhere on the page, offering more flexibility and robustness. Using relative XPath is generally recommended for dynamic web applications where the UI may change frequently. To launch a browser using Selenium WebDriver, you instantiate a driver object specific to the browser you want to automate. For example, in Java, you might use WebDriver driver equals new ChromeDriver to start Chrome. Once the driver is initialized, you can navigate to any URL using the get method. This simple process is the foundation for all further automation steps in Selenium. Selenium provides two methods for closing browsers, driver.close and driver.quit. The close method shuts only the current browser window with focus, while quit closes all open browser windows and ends the WebDriver session. Knowing when to use each method helps manage browser sessions efficiently and prevents resource leaks during test execution. Interacting with input fields is a common task in Selenium. To type text, use the sendKeys method, and to clear existing text, use the clear method. For example, you can locate a search box, clear any pre-filled text, and then enter new text. This approach ensures your tests are reliable and not affected by leftover data from previous runs. Selenium offers three main types of waits to handle dynamic web content: Implicit Wait, Explicit Wait, and Fluent Wait. Implicit Wait sets a default wait time for all elements. Explicit Wait waits for a specific condition, like an element becoming clickable. Fluent Wait extends Explicit Wait by allowing you to define polling intervals and ignore specific exceptions. Using waits appropriately makes your tests more stable and less prone to timing issues. While Thread.sleep can pause your script for a set time, it's not recommended in Selenium automation. This method introduces static waits, causing unnecessary delays and making your tests inefficient. Instead, use Selenium's built-in waits to synchronize your scripts with the application state, ensuring faster and more reliable test execution. Selenium provides methods to check if an element is displayed, enabled, or selected. The isDisplayed method verifies visibility, is enabled, checks if an element can be interacted with, and is selected, determines if a checkbox or radio button is selected. These checks are essential for building robust tests that interact only with the right elements at the right time. To click a hyperlink in Selenium, you can locate it using by link text or by partial link text, then call the click method. This approach is straightforward and effective for navigating through web pages or triggering actions linked to specific anchor tags. Selenium allows you to maximize or set the browser window to full screen mode using driver, manage, window, maximize, and driver, manage, window, full screen. These methods help ensure your tests run in a consistent browser state, reducing layout-related issues. The WebDriver in Selenium is a Java interface, not a class. It defines a set of methods that browser-specific driver classes, such as ChromeDriver or Firefox Driver, must implement. This abstraction allows you to write browser-agnostic automation scripts, making your code more flexible and maintainable. Selenium provides simple methods for navigating browser history. Use driver navigate back to go to the previous page, driver navigate forward to move ahead, and driver navigate refresh to reload the current page. These navigation controls are handy for testing workflows that involve multiple pages or require refreshing content. When using Selenium WebDriver or Grid, the default port is typically 4444. This port is used for communication between the client and the Selenium server, ensuring smooth execution of automation scripts across different environments. The findElement method returns the first matching web element for a given locator, throwing an exception if none is found. In contrast, findElements returns a list of all matching elements, or an empty list if none are found. Understanding this distinction helps you handle single and multiple element scenarios effectively in your tests. To interact with drop-down menus built using the HTML select tag, Selenium provides the select class. You can select options by visible text, index, or value. This makes it easy to automate form submissions and other workflows involving drop-down selections. Selenium can handle JavaScript alerts and pop-ups by switching the WebDriver control to the alert. You can capture the alert text, accept, OK, or dismiss, cancel the alert. This is essential for automating scenarios where user confirmation or acknowledgement is required. When dealing with multiple browser windows or tabs, Selenium uses window handles. Each window has a unique identifier, allowing you to switch between them as needed. This capability is crucial for automating workflows that involve pop-ups, new tabs, or multi-window navigation. Selenium cannot directly access elements inside an iframe without switching context. You can switch to an iframe using its index, name, ID, or a web element reference. After performing actions inside the frame, switch back to the main content to continue automation. This is vital for interacting with embedded content like ads, forms, or widgets. The Actions class in Selenium enables you to simulate complex user interactions such as mouse hovering, drag and drop, right-clicking, and double-clicking. To use these actions, you create an actions object, chain the desired actions, and call perform to execute them. This class is essential for automating rich, interactive web applications. To perform a drag-and-drop operation in Selenium, use the Actions class. Locate the source and target elements, then chain the drag-and-drop method followed by perform. This technique is widely used for testing interactive features like sortable lists or draggable widgets. Selenium allows you to capture screenshots by casting the WebDriver instance to the Take Screenshot interface. This is useful for debugging, reporting, and documenting test results. Screenshots can be saved to a file for later review, helping you quickly identify issues in your automation runs. The page object model is a design pattern in Selenium where each web page is represented by a corresponding class. This class contains the web elements and methods to interact with them. POM enhances code reusability, reduces duplication, and simplifies test maintenance, making your automation framework more scalable. PageFactory is an inbuilt Selenium class that optimizes the page object model. It uses annotations like a find by to initialize web elements dynamically when the page object is created. This approach streamlines element initialization and improves the efficiency of your test scripts. Selenium automation can encounter several common exceptions, such as no such element exception when an element can't be found, stale element reference exception when the element is no longer attached to the DOM, timeout exception for operations exceeding wait times, and element not interactable exception when an element is present but hidden or blocked. Understanding these exceptions helps you write more resilient automation scripts. A stale element reference exception occurs when the DOM updates and the element reference becomes invalid. To handle this, you can relocate the element before interacting, use explicit waits, or wrap the action in a try-catch block with retries. These strategies help ensure your tests remain stable even when the page changes dynamically. Sometimes, native Selenium actions may not work as expected. In such cases, you can execute JavaScript code using the JavaScript executor interface. This allows you to perform actions like scrolling or clicking elements that are otherwise difficult to interact with, providing greater flexibility in your automation scripts. In testing frameworks, assert, hard assert, stops test execution immediately if the condition fails, marking the test as failed. Verify, soft assert, logs the failure but continues executing the remaining steps. Choosing between assert and verify depends on whether you want to halt on failure or gather more information in a single run. To hover over an element in Selenium, use the MoveToElement method of the Actions class. This is especially useful for revealing drop-down menus or tooltips that appear only on mouse hover, enabling you to automate complex UI interactions. For file uploads using a standard HTML input element, Selenium lets you send the absolute file path directly to the input using sendKeys. This bypasses the need to interact with the file picker dialog, making file upload automation straightforward and reliable. CSS selectors are generally faster and cleaner, optimized by browsers, but can't navigate upward in the DOM. XPath can traverse both directions and search text dynamically, but may be slower in older browsers. Choosing the right selector impacts both speed and maintainability of your tests. Selenium doesn't natively read Excel files. To supply test data from Excel, integrate a third-party library like Apache Poi for Java. This allows you to parse XLSX or XLS files and feed data into your automation scripts, enabling data-driven testing. Desired capabilities and options classes in Selenium let you configure browser profiles, preferences, and behaviors. For example, you can run browsers in headless mode, disable extensions, or ignore SSL errors. These configurations help tailor the browser environment to your testing needs. Standard HTTP authentication pop-ups can't be handled using Selenium's alert interface. Instead, pass the credentials directly in the URL, such as http://username, password at site.com. This approach allows you to automate authentication flows that use browser-level dialogues. Selenium 4 introduces a new architectural workflow. Unlike Selenium 3, which used the JSON wire protocol, Selenium 4 communicates directly via the W3C WebDriver protocol. This change results in faster, more stable, and less error-prone automation, as modern browsers natively support the W3C standard. Handle dynamic web tables. Locate table rows and columns using relative or dynamic XPaths. Loop through the rows and extract cell values as needed. This approach is essential for automating data-driven scenarios, such as verifying table contents or processing large datasets. Selenium 4 introduces relative locators, also known as friendly locators. These allow you to find elements based on their position relative to other known elements, using methods like above, below, to left of, to right of, and near. This feature simplifies element selection in complex layouts. Standard Selenium methods can't access elements inside a shadow DOM. To interact with these elements, first locate the shadow host, expand its shadow root using JavaScript or Selenium 4's getShadowRoot, and then query within the shadow root. This enables automation of modern web components encapsulated in shadow DOMs. Selenium Grid enables distributed parallel test execution. In Selenium 4, the grid is restructured into microservices. The router directs requests, the distributor assigns sessions, the session map tracks session IDs, and nodes run the browser instances. This architecture improves scalability and reliability for large test suites. SVG elements require special handling in XPath. Standard tag names don't work, so use the local name, or name, function to match SVG tags. This technique is essential for automating tests involving charts, graphs, or other SVG-based visuals. Running tests in headless mode means the browser operates in the background without a visible UI. This saves system resources and is ideal for CI/CD pipelines. Configure headless mode using browser options, such as Chrome options with the headless argument. Selenium provides methods to add, delete, and manage browser cookies using driver.manage. This is useful for simulating logged-in sessions, testing authentication flows, or clearing session data between tests. There are three main test automation frameworks: data-driven, which separates test scripts from data; keyword-driven, which uses human-readable keywords mapped to code; and hybrid, which combines both approaches with page object model structures. Choosing the right framework depends on your project's complexity and maintenance needs. Selenium 4 integrates with the Chrome DevTools protocol, allowing you to listen to network traffic and capture console logs. This is invaluable for debugging, performance monitoring, and advanced automation scenarios like geolocation mocking or network throttling. Set up continuous integration with Jenkins, commit your Selenium code to a Git repository, configure a Jenkins job linked to the repo, set build triggers, and define build steps like MVN clean test. Post-build actions can generate reports, making your automation process fully automated and traceable. Event firing WebDriver and WebDriver Listener let you register event listeners to capture actions or exceptions automatically. For example, You can log messages before every click or take screenshots on exceptions, reducing the need for manual try-catch blocks throughout your code. When running hundreds of tests in parallel, ensure each test closes its driver session using driver.quit. Use Thread.local WebDriver for thread safety, and consider running tests on a Dockerized Selenium grid to isolate execution and prevent memory leaks. These practices help maintain performance and reliability at scale. With Java 8, you can use streams to filter and interact with elements efficiently. For example, to click a specific link from a list, filter the elements by text and use if present to click the target. This modern approach makes your code concise and expressive. Optimize execution speed in large regression suites, implement parallel testing, use efficient CSS selectors, fine-tune wait thresholds, and run non-UI validations in headless mode. Incorporate API calls to bypass repetitive UI steps, streamlining your automation for faster feedback and higher productivity.